We've now been through a number of the unary iterators, the iterators that have one input. We've seen simple ones like select. We've seen data access iterators like heap scan. And we've seen more involved unary iterators like sort and group by. And now we're ready to look at binary iterators as exemplified by joins. Okay, so we're going to look at a number of join algorithms next. And joins are pretty interesting in the way that they take advantage of memory and spill things to disk, and how that interrelates with the iterator model. In our examples, we're going to have a schema which is going to have these tables, reserves and sailors, and this cost notation. When you see square brackets around a relation name, that's the number of pages to store that relation. So square brackets R is the number of pages to store R. When you see P sub R, that's the number of records per page of R. And as usual, when you see vertical bars around R, that's the cardinality, or the number of records of R. And the cardinality equals PR times bracket R. Okay, so in our reserves table, we're going to have 1,000 pages of R. We're going to have 100 tuples per page, and therefore we're going to have 100,000 tuples total in R. In our sailors table, we're going to have 500 pages of S. We're going to have 80 tuples per page for a total of 40,000 sailors tuples. And we'll refer back to this as we go through our example join algorithms.